beta decay is a little bit more tricky. There are three types of beta decay. The most common is what we call the beta minus decay or electron emission. Okay, in this particular decay, we start with a parent, as always, but then we get a daughter and an electron that's going to be emitted. That's why we call it electron emission. Now, in addition to that, to have conservation of momentum and conservation of energy, we have what we call anti-neutrino. We'll talk a little bit more about that, but not much really, a little later. So that's the first type of beta decay. The second type of beta decay, it emits a positive electron. A positive electron, that's not something that we find easily in nature. It is what we call an anti-electron or a positron. Anti-electron or positron. Now, in this particular case, the parent is going to give a daughter. A positron is going to be emitted, and along with that a neutrino. But you notice this was an anti-neutrino. In this case here, it's going to be a neutrino. We have an anti-electron with a neutrino. Here we have an anti-neutrino with an electron. It's actually because there is the conservation of something else in addition to the conservation of energy and momentum that's discussed in particle physics that we are not discussing in this particular course. Okay, now the reactions. Sorry here that this first equation does not have the full notation, but we should have A here and Z here. So this is going to be A, and then it's going to be Z plus 1. Since we emit an electron to conserve the charge, the number of protons increase. So essentially a neutron is going to change into a proton and the electron and the neutrino. So that's what we get here. And then plus the beta minus, which is just an electron. An electron is just 0. And a minus 1. Okay, now for the beta plus decay, same thing. So we have A here. But since we are getting a beta plus, so it's going to be Z minus 1. And the beta plus is going to be 1, 0. Okay. Now the third type of what we call beta decay, it's actually the opposite of an emission, which is a capture, electron capture. That's the third type of beta decay. So in this case, what happens is the parent actually captures an electron. So the left side of the equation, we have two things. So as it captures an electron, remember the electron is 0, minus 1. So in this case, I have Z minus 1 to the left side for the charge, so I should have Z minus 1 here. And for A, it should remain as an A. And of course, we have the neutrino. Electron capture is equivalent to beta plus decay in terms of the conservation rules. Let's look at an example. A neutron, for example, here. We start with 1, 0. It's turning into a proton, 1, 1, and then an electron. So the conservation of A, we have 1 on one side is equal to 1 plus 0 plus 0. And then the conservation of charge, 0 on one side, 1 plus minus 1 plus 0. You notice the neutrino from the word neutrino, it is neutral. So that's why the charge is 0. And it's not a nucleon, so a number for it is 0. The nucleon number for it is 0.